Hello everyone. So we will be solving question number 62 of GATE 2026. This question is belongs to the op-amp circuits. Here to understand to solve this question, we need two concepts. One is a virtual ground concept. Second is zero input current. Before that, we will see what all has been given in this question, right? So you have a inverting amplifier. Please understand that you have an inverting amplifier. How I am saying that the input is applied to the inverting terminal here and you have a feedback. You have a feedback here. So this is an ideal op amp. Please understand it is an ideal op amp. To consider this as ideal op amp, we should have a open loop gain of infinite open loop gain AV, which is infinite. Then they are given the resistance R1, R2, R3, which is 50 kilo ohms. What is they are asking? Magnitude of the closed loop gain. What is the magnitude of closed loop gain? Where output is fed back to the input using the feedback circuit. Now we'll see what all concepts of we need. The first concept we need is virtual ground concept. What is meaning of virtual ground? Because of the open loop gain of an ideal op amp is infinite, the differential input between this terminal and this terminal should be zero. Differential input between the inverting terminal and non-inverting terminal should be zero for the output to remain finite. For output to remain finite. So if the non-inverting terminal is grounded, which is 0 volt, here inputting terminal also should be a 0 volt to make this input differential input is 0. I hope you are getting it that this concept is called as virtual ground concept. The second concept we are saying is zero input current. Zero input current. So what is happening? This is the input terminal. Here input current should be 0 because the input impedance is infinite here. Input impedance is infinite. All the current coming from the input from Vi must divert entirely into a feedback network like this. I hope you are getting it. Here we have input current is 0 because it has infinite input impedance, and the second concept is virtual ground. With this knowledge, let us solve this question. The one more thing to notice here is the feedback network. The feedback network which you have here is something called as P network configuration. The configuration looks like T configuration. So with this knowledge, let us solve this question. Now, I will assume this as 0 volt as said, this as Vx, and this is V naught. First, we will apply the KCL, KVL here, nodal analysis, and then here. So if you see, we have already seen whatever current coming current coming at virtual ground V minus. Why V minus? It is a inverting amplifier is equal to the current going out from V minus as per KCL. So VI minus V minus, that is virtual ground, divided by R1 is equal to V minus of Vx divided by R2. So we know V minus is 0 volt, right? Virtual ground concept. So substituting Vi or V1, whatever you want to call it, 0 by R1 is equal to 0 Vx by R2. R1 and R2 cancels because both are 50 kilo ohms. So we are getting Vx is equal to minus Vi. Please note down this equation. It will be helpful for us to solve the second equation. So now we will apply KCL and nodal at node Vx. So Vx minus V minus, that is virtual ground, by R1, Vx by 0 volt by R. So sorry, this is R2. You can see in the question. So R4 and R3, right? So this is R4. Then Vx minus V output is R3 is equal to 0. LCM is same because all are 50 kilo ohm. So Vx minus of V minus plus Vx minus V naught is equal to 0. So V minus already know it is 0 plus Vx minus V naught is equal to 0. Vx, it is 3Vx minus V naught is equal to 0. V naught is equal to 3Vx. V naught by Vx is equal to 3. This is our second equation. So now if you substitute equation 1 in equation 3, 2, so Vx minus Vi is equal to 3. Vx by Vi is equal to minus 3. As they are asking magnitude in the question, so our Vx minus by Vi is minus 3, which is 3. This is the answer. This is the procedure to solve this question by knowing the virtual ground concept and zero input current and T configuration. If you want to solve this question directly with the help of formula, whenever the feedback network is given, T configuration in feedback, we can use directly this formula minus R2 by R1 1 plus R3 by R2 R3 by R4. So if you substitute 50 by 50, 1 plus 50 by 50, 50 by 50. So this cancels, this cancel, this cancels. So this is 1 and this is 1, 1, 1, 1. This is 3. So your closed loop gain for this question is 3. If you have any doubt, you can put it in the comments. Thank you.